particularly rapidly in this particular case. Now, what I want to do, I have now shown you some examples of changes occurring with different types of, with the magic fire. Here I have some magic cards. What I wanted to show you next, of course, is my favorite topic, which is fire, and to give you a few examples of different types of fire. We have here a flame which has been burning for many, this type of flame has been burnt by people for many years. And what it does, it's a flame which wax is burning. There is a wick there, and there is a little bit of smoke coming off, you see. And what I wanted to show you is that there are other types of flames. This has been burnt by thousands of years. Indeed, fire, the conquest of fire by man, was one of the greatest achievements of early civilizations. People used to watch flames burning in volcanoes, they used to watch lava burning, etc., and they used to wonder and amaze. And it was a great triumph of early civilizations where they could rub sticks together to make fire. Well, they had a fire piston which they would hit and the tinder would start burning. Or when they could make the fires by flint, you see. So this was the type of flame was burnt for thousands of years. I wanted to show you, though, some slightly different examples of flames which people can observe here. Now, I'm going to start off by demonstrating for you something which is popularly called, among magicians, magic volcano powder. Now, here it is, and as I've poured out some powder, it looks like a beautiful orange powder which could almost be sherbet, you see. But what I wanted to tell you is, this of course is not a magic show, it's a chemistry lecture. What I've actually got here is something called ammonium dichromate, and one of the most important things in the world of chemistry, or indeed in the world in general, is to read the hazard symbols. The hazard symbols on this, you see there's a flame, which tells you it's an oxidizing agent. Skull and crossbones tells you it's a deadly poison if you take it in. There is a picture of a hand being burnt with a liquid. This tells us that it's strongly corrosive if you dissolve it in water on your hand. And finally, a picture of a man seeming to have a heart attack. Basically, it's a carcinogen. In a nutshell, this substance, ammonium dichromate, is very toxic. However, if we handle it in the proper way, then it is perfectly safe. And I just wanted to tell you, there is a particularly beautiful type of reaction which takes place when we actually put a flame to it. It's an example of a reaction. It resembles a volcano. Please watch carefully. It takes a little while. This is not easy to do, this reaction. And there it is just starting now, and I'm going to tilt it upwards so you can see it a little bit better. You see, it resembles a miniature volcano. There is a cloud of ash rising from it, just like a miniature volcano. Now, this type of reaction is called a thermal decomposition. The ammonium dichromate is breaking down into simpler substances. Now, you will notice that as the reaction proceeds, there is no smoke produced whatsoever. This, you see, is producing smoke, as I will shortly demonstrate. Here there is some steam. That looks like steam, and it is steam. And you see the reason, you will not notice any smell. There is nothing here that will pollute the air, because the only two products of this that have gone into the air are nitrogen gas, which is part of the air, and steam, which is also part of the air as water vapor. So there is no change whatsoever in the air around us in a way which we would notice. But you'll notice the orange powder has chemically changed. It has now become a dark green powder. This is called chromic oxide. This is nowhere near as toxic or harmful as the ammonium dichromate. So, another example of an interesting chemical change. Now, dear children, I've made a bit of a mess. Many of these experiments make a mess, and always this is normal when we carry out many processes on an everyday basis. And for this purpose, of course, it is necessary to sweep up our mess. Now, we have a special, I always carry a dustpan and brush with me, and I'm going to sweep up. If you don't mind, I'm just going to do a little bit of tidying up, and I will be frequently tidying up during the course of today's lesson. And the reason is that if we keep learn to be tidy, then we are well organized and we can hopefully achieve the results that we want to achieve. So please watch carefully there, and as I just sweep that up there, and I've got my pile of ash, and I'm going to put it into a special sand bucket which I have at the back here. So I've popped my ash into the bucket there, and we are now ready. I'm just going to tip this in here, and I'm now going to move on to my, by the way, if things start smouldering at the back, do alert me, okay? Because that ash was still quite hot, and there was some plastic in there, and if you do notice some smouldering, don't hesitate to shout out, and we shall make the necessary arrangements. Now, what I wanted to move on to is something which you're all very familiar with. I have it in this bottle here, and it's labeled petrol. Petrol, of course, is to make motor cars go forward, that it's put into car engines. And I wanted to tell you that you probably know that cars are a modern invention. Cars have been around for about 125 years or so, and that is a true wonder of the world of engineers. And the science of physics and mechanical engineering combined together have given us motor cars. But petrol, you see, substances similar to petrol have been around for thousands of years. Petrol is not a modern invention. You see, for thousands of years, people have been burning all sorts of fuels, whether it's wax like this obtained for animal or plant origins, or whether it's oils that have come out from plants or animals. And this substances similar to petrol would have been made from an oil which oozes out of the ground, which is called crude oil. Today, we make huge numbers of substances from crude oil. Indeed, you are all sitting on plastic chairs, which once upon a time were crude oil. The number of substances made from crude oil is quite remarkable. This is the triumph of the modern science of chemistry. Now, how would they have made substances similar to petrol? They had simple techniques for distillation, we know, because the apparatus exists, and they were able to obtain substances similar to this. Now, what I wanted to show you is how substances similar to petrol used to burn, or how people used to observe these burning for thousands of years. I'm going to do this, and once I've done that, I'm going to show you how petrol burns inside a motor car engine and explain to you how the contribution of the chemist has radically altered the world that we live in for our benefit. I'm going to start off by burning some petrol on an open mat, which I have here, and just show you, and there it is, a tea pipette full of petrol. I'm going to pour it on there, and then I'm going to replace my top here. Petrol is very flammable indeed. And I'm going to then set it on fire and ask you to ask yourselves the question, do you think that this is the way that petrol burns inside a motor car engine? And there it is. Now, you see, please watch carefully. The wood is burning with a yellow flame. The petrol is burning with a yellow flame. The candle is burning with a yellow flame. This is producing a huge amount of smoke. You can all see that. It's not surprising that people didn't use this. This is far too smoky for any purpose, for any use. You couldn't provide light with it. You couldn't provide heat because of the huge amount of smoke that was being made. And if we show even a candle flame, let me just show you. If I hold my porcelain, white porcelain container, evaporating basin, please watch happens as I put it over the candle flame. And you'll notice in a short space of time, a black deposit, you see. Now that black deposit is the common ingredient to all three of these fuels. It's what's found in there, in the petrol, and in there. It's what gives the smokiness. It's carbon. You see, wood is a form it's made of compounds called cellulose, which grow in nature, which are very rich in carbon. You can see the black ash left there. Petrol is a mixture of hydrocarbons, compounds with relatively short molecules, but wax is a mixture of even longer molecules, and this burns, it produces smoke, as you can see, but nowhere near as much as that. Now allow me to show you how the chemist